Hello everyone. As part of learning generative AI, we have learned how various models are performing, how the pre-training is happening and how the fine-tuning is happening, what are various applications they are doing, and we have concentrated on some of the applications in detail. In today's session, we'll be talking about various open AI models which are also contributing towards various applications in the generative AI domain. So let us start with XLNet, which is again a transformer based model which shows improvement on BERT. BERT actually what it does, BERT is going for masked language model, whereas XLNet uses bidirectional pre-training. It goes for a kind of autoregressive model which combines bidirectional model of BERT. So this pre-training model combined with bidirectional plus autoregressive makes XLNet comparatively a better model to BERT. So when BERT is using masked language model, XLNet uses autoregressive pre-training method which is capturing bidirectional context. So what is the added feature? Both BERT and XLNet, they are having bidirectional context capture. The additional feature in XLNet is autoregressive modeling. So let us talk about where XLNet is making advantages with this autoregressive nature. This autoregressive modeling combined with bidirectional context capture makes the XLNet to identify various dependencies between the words in a more flexible way compared to the BERT. When it is trained to predict all possible permutations of the sequence of tokens, what it will do is it takes the benefit of identifying the context in any manner, from left to right or right to left manner, it can identify the context. So let us see in detail what are the key features of XLNet. First one, autoregressive pre-training. As I mentioned, BERT is using masked language model wherein some of the words will be marked or some of the words will be masked. You are going to replace them with a mask, and the model has to identify the context in spite of masking some of those words. So it is trying to use masked language model, whereas XLNet is using permutation based autoregressive pre-training objective. Please concentrate on these words carefully. Permutation based autoregressive. What it is trying to do, what do you mean by permutation based? Whenever it is trying to generate a sequence, it is generating a sentence, text generation. What it will do is it will try to generate all possible permutations and combinations of the sequences. Say for example, I am trying to say the sentence, my name is SRIDEVI. Now try to generate, my name is SRIDEVI. There are 4 tokens. Try to generate all possible permutations and combinations of these 4 words, right? So the XLNet is trying to generate all possible permutations of the token sequence, and then it will try to identify what could be the next token. I have already generated a permutation of these 4. What could be the next token, right? For every permutation, it identifies what is the next token. This allows XLNet to capture bidirectional context while still maintaining the autoregressive properties of models like GPT. So what is happening when you are generating all possible permutations of these tokens that have been generated so far? Do we get one combination where all the tokens are given from left to right, and one more permutation will be there where the tokens are given right to left? So it is trying to capture the context in both the directions, thereby taking advantage of giving a proper text, right? Then bidirectional context, as I keep on talking, whenever it is trying to model, what it is trying to do is it is trying to model the full context of the sequence, left to right as well as right to left. This is similar to BERT, right? However, BERT is going for masking certain tokens during the training phase, whereas XLNet is doing permutation based training method, wherein for every permutation it will try to generate what could be the next token. This makes XLNet to capture the dependencies in either directions. Then enhanced dependency modeling, because XLNet is trying to identify the dependencies between the tokens for every permutation, it is trying to capture the long range dependencies very effectively, and it will try to predict what could be the next token based on the order of the permutation. Then unsupervised pre-training and fine tuning. Similar to BERT, XLNet is trained on a large corpus of text data in unsupervised manner. Once we go for pre-training, what can we do? We can go for fine tuning to perform specific tasks like sentence generation, translation, question answering, likewise. Better handling of contextualized representations. What do we talk about this feature? XLNet has shown an improvement on BERT. What kind of improvement it is showing? It is capturing the context in a better manner with word representations. What are the contextualized word representations? When we are trying to generate various permutations, you can definitely understand how each word is fitting into the context and which sequence of words can be relevant to the context, right? This is achieved by modeling how tokens depend on each other in every possible permutations. Otherwise, in BERT, what it is doing, it is going for a fixed context vector using the MLM, masked language model. Dynamic contextualization, what is this one? The permutation based training technique which is used in XLNet makes it more dynamic context, wherein the model is trying to identify different orderings of the tokens, and whenever it is trying to go for training as well as fine tuning, and also during inference of the sequence that has been generated. Higher performance on NLP benchmarks. XLNet, compared to other models, it has shown more performance compared to all the other models under the domain of various tasks of natural language understanding, wherein it is working or it is giving better performance in tasks like sentiment analysis, question answering, natural language inferences, etc. Why it is possible? Because of its unique pre-training approach. What is the pre-training approach we are following here? Permutation based autoregressive, right? Generalization ability. The permutation based training approach helps the XLNet model to generalize to new as well as unseen data compared to rest of the models. Even if you get a new data, it can try to adjust to that and it can try to take the inferences from the data. Because of this, XLNet is a robust choice for various applications of natural language understanding domain. Large scale pre-training. Like other models which are trained on large corpus of text data, XLNet is also given training, pre-training on large scale and vast amounts of text data, which makes it understand the new patterns of the language, the new intricacies of the language, and it is able to perform better. So overall, XLNet is a key innovation, and its ability to combine the strengths of autoregressive as well as bidirectional context is making it as a better model and an advanced model under generative AI. So what are the applications where we can see the usage of XLNet? Maybe under text classification, wherein we are trying to segregate mails which are useful to us or which are spam, something like that. Question answering, natural language inferences, wherein you are trying to identify the relationships between sentences and try to understand. Text generation, we have seen the text generation application using GPT-2 model. Now an XLNet can also be used for generating a text by giving a prompt. Translation and summarization, we can go for machine translation as well as abstractive summarization tasks. XLNet can give better performance. So XLNet is doing better in these applications, but this is not only the set of applications that are limited with XLNet. The next advanced model is T5. T5 stands for text to text transfer transformer, right? So what exactly is this one? T5, it's a transformer based model which is trying to do all the NLP tasks wherein it is trying to concentrate only on text to text. What is the meaning of text to text? You give input as text, the output from the model is also text, right? Whether it is classification, translation or summarization, whatever is the thing, you are trying to give text and you are going to get text from the model. For example, you are trying to go for classification. I have given set of emails, right? Or I have given set of sentences. From that, which are normal sentences which are useful to me, which are not, which can be discarded. So you are trying to give a text information and it is trying to do the classification of useful sentences, not useful sentences. So again, the output is a text information. Similarly, translation. You have given a sentence in French. It's a text information. And the output from that, you wanted it to translate from French to English. So the output of the model is also text information. Likewise, T5 is pre-trained on a denoising auto-encoding objective. What do we mean by that? Whenever you are pre-training the model, you introduce some noise into the input data. Whenever you are trying to introduce some noise and then you are trying to predict what is the missing text or corrupted sentence, because you have introduced noise, you might have some text missed or you might have corrupted a sentence. So once you introduced the noise, you are asking the model to predict the missing data or the corrupt sentence. Suppose it is able to do that, we say the model is performing effectively and we try to see T5 is doing it in bidirectional context. And the model, once it is learning with this auto-encoding combined with denoising, we can put the model for fine-tuning tasks wherein you are trying to give normal task instructions by giving an input text and making it generalize for various tasks. Quickly look at the features of T5. Text to text framework, as I mentioned, the input is also text, the output is also text. Unified architecture for multiple tasks. It can be used for various types of tasks like question answering, summarization, translation. No need for task specific training. Pre-trained on large text corpus, it is trained on the large text corpus data set which is C4, and the data set is of very large quantity, high quality web scraped text data. Because of this pre-training, it allows to learn the general language patterns and contextual representations. And I have told you, under T5 we are going for a pre-training model wherein autoencoder is combined with denoising. Because of this, the model is performing better. This is one of the key features of T5 model. Flexibility with task description. You can give the tasks in a very simple English-like sentences like summarize this particular paragraph, translate this sentence from French to English. So it is easily understood. The instructions that you are giving to the model are easily understood to the user. Scalable model sizes. it can work on a small range of model version to a larger version, right? We call them as T5 small or T5 11B. This scalability, because of which you can work with any kind of model wherein you have resource constrained option, right? Fine tuning. After pre-training, T5 can be fine-tuned for any kind of specific downstream tasks. Downstream tasks means you are trying to narrow down the input data set that it has to consider, and you are trying to ask the model to perform task specific works, and by giving the task specific prompts. And multilingual capabilities, T5 model can work with various languages. So you give the text in French, ask it to translate into German. You give the text in Italian, ask it to translate into English. So it can work with multiple language based, and you need not have a separate models for each of these languages. What are the versatile tasks it can perform? It can perform text summarization, it can do translation, question answering, text classification, generate the new text, and paraphrase the given text, right? So it is trying to do various tasks of NLP. And strong performance on NLP benchmarks, when T5 has achieved wonderful results, state-of-the-art results on various NLP tasks such as glue, super glue, squad benchmarks, because of which it is very highly effective for complex NLP tasks. Simplified model and fine-tuning process. Because it is text-to-text design, pre-training as well as fine-tuning become very simple and more consistent. So, because of its flexibility, unified architecture, and the specific feature of denoising with autoencoder pre-training, T5 is also one of the advanced open AI models for NLP or NLU based tasks. So what are the applications of T5? These are some of the applications. Because I have listed 5, don't think this is limited to only these 5. I have just listed some of the major applications of T5. So in the next class or next session, we will be talking about how do I compare XLNet with various other models, like we have learned T5, we have seen BERT, we have seen Roberta, we have seen Albert. So let us compare XLNet with rest of the models. Thank you.